Hi class, we continue with this property table for water type of working fluid. So we are going to have the next example with a second approach where given to you pressure and specific volume. So the rules of thumb, when we're given to you pressure and any of this extensive property, we are going to read it from your property table, which is table A5, where you have the first column is for your pressure. So in this example, we're given to you pressure at 200 kilopascal and specific volume is 0.56. So let's have a look at your property table here with 200 kilopascal. So you have a 200 kilopascal and specific volume, right? Yes, your specific volume. Okay, so given to you 200 kilopascal and the specific volume is 0.5. So you can see that 0.5 lies in between 0.00 and less than 0.8. You have 0.5 here. Okay, so you have, if we have a look at your, TS diagram over here, so if you have a look at your property table here, so this 0.88578 is actually your saturated vapor, and it lies in this point here, right? And the other one is at saturated liquid line here, right? So what was the value at saturated liquid point there? If you check on your property table, it's going to be 0.001061. Right? So given to you in this question is 0.56578. So it must be in between this area. Okay. So thus, the phase description now is in saturated mixture, where this is when the boiling point and the change of liquid into the vapor phase, right? So what will be the temperature at this boiling process? So we have a look at your table back. At 200 kilopascal, the temperature is 120.21 degrees C, right? Okay, so this is how you read your property table if given to you pressure and specific volume. Okay, now we have the third example with the third approach, where you are given temperature and pressure. So the rules of thumb, when you are given pressure and temperature, you are going to read this from your superheated table or table E6, where in this case you are given 1800 kilopascal, which is equivalent to 1.8 megapascal. So let's have a look at 1.8 megapascal. Yeah, so you have this one, 1.8 megapascal at 350 degrees C. So 350 degrees C. So the reading for the specific volume at this point, where you have 1.8 megapascal, 350. So the specific volume here is 0.5460. Okay. Right, now what about the phase descriptions? Okay, right. So let's say the 1.8 megapascal or 1800 kilopascal is this line, right? So at this point, the boiling temperature or saturated temperature is actually this one, saturated temperature. Okay. it's about, let's say it's about 200 something, but in the question given to you is 350, so it must be on top of here, 350. Sorry for the bad handwriting here, but I think you do get my point, right? So this is 350 point, 350 degrees C. Okay, so the specific volume need to be in here, right? So you see this point now lies in this region, which is this superheated vapor region. Okay, thus the description here is your superheated vapor, and therefore we need to read it from your superheated water table, right? So in this video we have completed two types, which is one is given to you pressure and any of this specific volume, and the other one is pressure and temperature. So in the next video I'm going to show you an example on how to find the X, or quality of X, where quality of X is when you need to determine at what point in this line, at what point is the phase of your water changing. How many percent of the water have changed into vapor, and how many percent left in liquid form.